The differential form of the fundamental laws, tutorial number 8. A uniform compressible flow occurs in a constant diameter pipe. Write the simplified differential continuity equation for the steady flow. In this question, we have a situation like this. We have a pipe wall here. Might be a circular pipe wall, but the velocity of fluid here is moving from left to right. So it is okay for us to evaluate this movement in Cartesian coordinate. So we have x-axis here and we have y-axis for this situation. So pipe wall will not move, means the velocity of pipe wall here is 0, and fluid here will flow by velocity of u as mentioned in this situation. So this is the continuity equation. We learned about this in our previous lesson. I hope you could remember all terms of the continuity equation here. And then we need to make an assumption. So we make del rho over del t is equal to 0 because it is steady flow and the density not change with time. We assume that del v over del y is equal to del w over del z equal to 0 because it is a uniform flow, velocity not change with location. And the velocity of v and w here is equal to 0 because there is no velocity in y and z direction. So we substitute all the assumption here in this continuity equation. We could simplify it as this one as our final continuity equation for that situation.